All right, so we are going to start our unit on force and motion. It's our physics unit. And our I can statements are going to change way more often than they did in ecosystem, body systems, and genetics. They will change, not daily, but very often, because right now I need you to be able to identify the different things that affect the motion of an object, whether that's friction, whether that's gravity, whether that's a push or a pull. I need you to understand that. And the reason why I need you to understand all of those vocabulary words is when we add or subtract those words, I need you to understand that. So in order to, when we add and subtract, you can tell me what's going to happen to that object. And I don't think that that's very difficult. There's an object rolling on the floor. We add friction. It slows the object down and stops it. We roll an object on the floor and we subtract friction. The object's going to roll way further than it normally would have. Those are the kind of things that we're going to be looking at as we first start. And we're starting off with a push or a pull. Now, for us, because we're going to do the video this way, we're going to take notes and then watch the video second. I can't play somebody else's video and then put that on my YouTube channel. That is a violation of copyright, and I don't want to lose the YouTube channel because that would be a bad day for all of us. So we'll come back to that. The first thing that we're going to talk about is force. And it is probably the easiest one that we're going to write down for today, because a force is a push or a pull on an object. I will give you a moment to jot that down. So again, as we start to study all of these things about force and motion, it depends on how things work. We have had some, when I say visit the classroom, I mean like virtually visit the classroom, scientists that studied forces in motion, some physicists, some tribologists have come into the classroom before through some things that we've done online. And we talk about the pushing and pulling and the things that slow those pushes and pulls down in our life on a daily basis. And you can make an entire career out of that. I know right now Grant is very interested in physics. He wants to be one of the people that gets into probably a very, very high level of engineering and build roller coasters at places around the world. But you have to know a lot about pushes and pulls, and you have to do a lot of math facts about if my train, it goes up this high on this track and it goes down this much of an incline, the next hill has to be this and can only be inverted this much and only this much of a curve because of G-forces and the forces on the track. There's a lot of math involved in that. But again, it's all physics and forces in motion as we start to talk about that. Forces act when things touch. Like today, I mean, I watch people outside. Not a lot of kicking of the football. There's a lot of kicking of the soccer ball. But when you were throwing the football or you were kicking the soccer ball, it doesn't just stay in the air. Sometimes there's a force that pulls it back down. And I know that that's the next force we're going to talk about. And the next thing that we take our notes on, that's going to be gravity. And gravity is a force. It's an invisible force. You cannot see it. That is going to pull things towards the earth. Now, gravity is not just on earth. You'll notice that I just wrote about earth on here, but when the notes, when we start talking about gravity, you're going to see where it talks about an invisible force that pulls objects towards each other. Like the sun has gravity. It's actually pulling on the earth right now. The moon has gravity. It is kind of wild. I know Sterling and I kind of got into it, and he had a little deeper understanding of it than most folks, and that's okay. Like everything has gravity, but most things aren't big enough to exert that force on something else, right? I mean, Gavin has gravity, but we're not all getting like pulled to the middle of the room towards him because he's not the size of a planet. Like then he would. Then you'd be like, what is that, Galactus in Fantastic Four. He might have gravity and pulling things towards him, right? So, I mean, that just depends on how those kind of things work. So we'll get into that as we move on. So forces, pushing and pulling. Not going to do this because I remember that and we didn't need to do that. Here's another video that I'll come back and watch for my folks at home. I'll post the codes today if you need to go back and watch and do some of this stuff. We'll do that. Next up is gravity. If you had to define gravity, what would your definition of gravity be? What would you say this is gravity? Evan. An invisible force that pulls objects down towards the floor, okay? Ava. Sure. If you drop something, it doesn't just stay there. It actually gets pulled towards the ground. So let's get our definition for gravity out here now. Let's see here. Gravity, a force that pulls things towards the earth. That's kind of what Evan was alluding to, like if you things get pulled towards the ground. It is an invisible force that pulls objects towards each other. As I was saying, gravity does not just occur on Earth. When you are on the moon, there is gravity, but if you've ever seen those videos of people on the moon, when they take giant steps, they're off the ground a lot longer than we are, right? They're kind of bounding across the moon because they're not getting pulled down with the same amount of force. There are some planets that if you were on them, it is pulling you with a much greater force than you're being pulled on the Earth. And I'll try to find that because it's funny because people are like, I want to live on the moon because I would only weigh this much on the moon, where if I lived like on Venus, I would weigh 10 times what I weigh now. I'll try to pull that up while you guys are writing that down. All right, so we've had time to take our notes on gravity, which is a force that pulls things toward the earth. It's also an invisible force that pulls things toward each other. Again, gravity is going to affect the motion of an object. If we can't be quiet, you're going to have to sit in the hall. We have too much to do. All right. When you jump, your legs do push you away from the ground. I've seen a lot of you do this outside. And you do have enough force to overcome some of gravity, but you can't stay off the ground, right? Gravity pulls you back down because you're not using enough force to overcome gravity altogether. You would need like a jetpack or something to do that. Not going to do that today. We'll watch this in just a moment. But that brings us to friction. Friction is when two objects slide against each other. Now, Bella, as objects are moving against each other, even my shoes and the floor, there is a small amount of heat that builds up. I don't know if you've ever done this before, if you've ever been riding your bike really fast and you slam on the brakes and you get off and you feel the back tire and that one spot's really hot. Who's done that before? I got grounded so much about that when I was little. Now, an easy way for us to feel that right now is to take our hands, put them together, and start rubbing. Two objects rubbing together, I already feel the heat. Do you feel the heat? All right. As we looked against friction and we rubbed our hands together and we pretended that that was like an engine, and then we put some hand sanitizer on our hands for the oil of an engine, we noticed that there was no heat building up. But as the hand sanitizer went away, we started to notice that that heat came right back because there was more friction in our hands. Friction is when two objects rub against each other, Noah, and there is a heat due to that. But friction also slows things down. Sometimes, Lily, sometimes you want there to be friction. You don't want an oil in the way. And that would be like your brake pads, right? You have the rotors, you have the brake pads. They squeeze together, they cause a lot of friction, and it causes your car to slow down. And depending on how much pressure you put on your brakes, your car can slow down very slowly and gradually or immediately stop, which is what I wish that lady that was behind us would have done, but she did not. She kept on moving. And then she stopped when she ran into us. But friction. Friction is when two objects rub against each other. This causes heat. Friction also slows things down. Now, I know for me, I would have like no problem whatsoever playing a round of bowling if I had bowling shoes on, back table. Because bowling shoes are very slick on the bottom and the bowling floor is very slick. And when you walk up to bowl and your foot slides across the floor, that is to help you throw the bowling ball. If you have ever tried to bowl in regular shoes, you will break your ankle. Because you're not meant, like you stop like immediately, and you've got this 8, 10, 12-pound bowling ball that you're throwing, and it starts to pull your body weight in ways that you're not used to, where if you have the bowling shoes on, you slide across the floor just enough to let the bowling ball go and hopefully get a strike. All of those pushes and pulls and friction are playing a part in our lives all the time. All right, looking at the time, we're still okay in here, so I'm going to keep going on. The last class was not able to make it to this. Looking at the ice skates and the ice, would you consider this a time when there is a lot of friction, or this is an area where there's not a lot of friction? Not a lot of friction, and that's what you want. You do not want to go out there on ice skates and have to stop. You want to glide across the ice. That's understandable. But if you are outside hiking in your boots on gravel, is there a lot of friction between these two things or very little? There's a lot, and that's purposeful. A lot of our shoes are made in very specific ways. If you look at running shoes, trail shoes, basketball shoes, cross-training shoes, football practice shoes, all of them have very specific designs on the bottom of them, even when you get into cleats, for very specific reasons to increase the amount of friction or decrease the amount of friction or give you just the right amount of friction. You cannot go out there. I would love to see this happen. You could not go out on the basketball court in bowling shoes and play a game of basketball. You would be sliding all over the place. But you also can't go out there in shoes that don't have, they just stop immediately. That's when you roll your ankles. They have to have just enough. And that's why you hear all that squeaking and moving, because the shoes are sliding and squeaking across the floor just enough. But again, they're constantly analyzing and redesigning those shoes. All right, take a look at this train. Would it take a little bit of force or a lot of force to move this train? Okay. What about this one? Okay. Who can tell me why it would take so much force to move the big one and no force to move the small one? Abel. He is on the right track, because I know on Earth that this word and weight are very similar, but as we saw when we plugged in on that other website, it's not the same. All right. We are going to look, maybe, if it's going to go on, at mass. This is our last vocabulary word for today. Mass is the amount of matter inside of an object. The amount of matter inside of an object. Now, Bella, if I gave you a choice, we're going to go outside at recess tomorrow, right? You're going to stand against the fence. I'm going to take about 10 steps back. And I've got either a golf ball or a ping pong ball. Which one are you letting me throw at you as hard as I can? You're letting me throw the golf ball at you and hit you with it? Well, I can't wait for recess tomorrow then. Really? You'd rather me hit you with a golf ball than a ping pong ball? No, the golf ball would, might break something. The ping pong ball is going to, it's going to sting and it's going to be funny. The golf ball would hurt, right? Because it has more stuff in it. It has more mass inside of it. So let's take our notes on mass. For the folks on here, you can pause whenever you need to pause and take the notes. Other than that, subscribe and like and all that other jazz, because we don't have time for all that. All right, I'm going to open this up. Then I'm going to freeze this. Mass, the amount of matter inside of it. Close the whiteboard. I don't even know what that's from. Go away. There we go. I just need the mass is the amount of matter inside of an object. All right.